In this lesson, we're going to talk about accessing list elements. We'll begin by first creating a list. Again, we'll work with numbers. This time we'll create an initialization list. Give us 10 elements, the numbers 1 through 10. And let's say I want to display the first two. So I do that by using something called subscript notation, where I reference the list name and then the element I want, the numbered element of the list, in a subscript, which is actually the number in between two brackets, like so. So here's code to access the first two elements of the list. Notice that the first element in the list has a subscript value of 0. That's because we number the positions in a list starting at 0. Sometimes this is called offsets, so that the first element is at offset 0, the second element is at offset 1, the third element is at offset 2, and so on. I don't commonly use offset, I usually just say subscript. So let's run this code real quick. So 1, 2 are our first two elements, so that's right. And that's all you have to know about accessing list elements, at least for the purposes of this lesson. Now let's look at a little more involved example. Let's say we want to compute the sum of the elements in this list. So to do that, first thing we're going to do is create a variable called sum. Then we're going to write a loop. Yes, I know in the first lesson I used a method sum to return the sum easily, but I want to demonstrate how to access elements. We'll get back to the sum method later. So the code is for int I equals 0, I less than numbers dot count. Well, let's think about that for just a moment. Count returns the number of elements in a list. So in this particular list, there's 10 elements, 1 through 10. But the I is going to represent the subscript. So if we went to 10, that would be one too many. The last element is at subscript 9. So we want to go less than count by 1. So we don't want 10, we want 9. Then we want to increment I by 1 each time. And then we're going to write sum plus equal numbers sub I, so that we get each element of the list by its subscript. And then we'll write out our result. The sum is, and that sum should be 55. So let's run it. And it is. Let's work with one more example just so you don't think everything is based on numbers here. Let's create a list of strings and access those elements. So we're going to write list string names equals new list string. And we'll write 4 names here very quickly. Let me scoot my panel over, give you a little more room so you can see what I'm doing here. Here we go. For int I equals 0, I less than names dot count, plus I, console, right line, names sub I. I'll say sub when I'm talking about the subscript. Let's run this piece of code. And there's our 4 names. So to sum up, when we want to access list elements, we use the subscript to reference the position of the element in the list. This is not the only way to do it. Later in the course, I'll show you how to access list elements using something called a for each loop, where we don't have to reference a subscript or a position at all. But for now, because all we know is the for loop, we're going to have to do it by subscript. We write a subscript by putting the number of the element we want inside brackets, and of course it can be a variable as well. One thing we don't want to do is try to access beyond or before the first element in the list. That will cause an error of some type that we want to avoid. So that's why in our for loop, we always write loop control variable less than names.count. By doing that, we ensure that we never go beyond the end of the list. So rather than put a number in, like 9, because I think that's the size of the list or the count, I'll just use the computer to compute that for me. So names.count will always be correct. Accessing list elements is quite simple as long as you understand the subscript notation. So let's move on to the next lesson where we look at how to use lists in method calls.